Hello friends, welcome to ECH. So today we are gonna understand about the 300 watt full bridge converter design in LTSpice. Okay, so in the last video we have understood about the 2 kilowatt full bridge converter design. If you haven't watched that video, I highly recommend you to go and watch that video before watching this video. Why? Because on that video I have explained the very basics of full bridge converter, which I am not going to explain in today's video. Okay, so let us understand first for what is the design requirement for 300 watt power supply. Okay, so let us say you want to design the 300 watt power supply for automotive domain, and your input is 48 volt and you want to design the output of 12 volt for, let us say you want to charge your car battery by using 12 volt power supply. So your output is 12 volt, your input is 48 volt, and your power rating is 300 watt. That is our design requirement for automotive domain. So friends, if you're new to this channel and you want to learn the hardware design or LTSpice design directly from me, you can join the very popular program of this channel called mentorship program. Once you sign in the mentorship program, you will get opportunity to directly interact with me virtually, wherein I'll train you about the LTSpice design and hardware design. So now let us understand about this 300 watt full bridge converter. Okay, so let me start explaining the circuit first. So you see here I have given V1, which is 48 volt. Okay, and then you see here I have connected one bulk capacitor, that is C3 1000 microfarad, and you see there is a 4 MOSFET connected in this fashion. So this is basically a full bridge topology wherein you can see 4 MOSFET is connected. Okay, so MOSFET M1 and MOSFET M4 are turned on together, and MOSFET M3 and MOSFET M2 are turned on together. And in between MOSFET M1 and MOSFET M2 there is a time called dead time, where at that time both MOSFET are turned off. Okay, then you can see here M1 is, I have connected the transformer primary winding to like this. One end is connected to the M1 source and other end is connected to the M2 source, right? So this is basically a coupled inductor. L4 is a coupled inductor. Okay, in spite of using transformer, I used here a coupled inductor. Now this is the secondary side of the full bridge converter, wherein I also used again the coupled inductor. You can see the coupling between L4, L7, L8 is 1. Then you can see here this D1 and D6 are the rectifier diode, and then we have output inductor and the capacitors. This forms the low pass filter. The load is here is 480 milliohm, right? 480 milliohm. So that is all about the basic design of full bridge converter. Okay, now let me show you how will you drive your gate of this MOSFET. As I said, M1 and M4 are turned on together, M2 and M3 are turned on together. So we need to have some gate driver for all these 4 MOSFETs. The duty cycle is 0.5, and you see we have the dead time of 40 nanosecond, right? As you see, the gate driver for MOSFET M1 is VG1 and VP1. So this one first is VG1 and VP1. If I right click on here, you can define this parameter in your LTSpice to get the same signal what I have given here. So for M1 we have VG1 and VP1. For M2 we have VG3 and VP2. So this L2 source is for M2 and this L5 source for L1. Both M1 and M2 are high side MOSFET, so we need here the high side MOSFET gate driver. Now like M3 and M4, we need low side gate driver. For M3, let's say we have VG2, so we have L6 as a driver, and for M4 we have VG4, so this L1 is a driver. So these things you need to design very carefully, otherwise your converter won't work. So that gate driving is more critical part in the full bridge converter design, right? Gate driving and the selection of the component. So guys, I haven't built and tested this circuit in the actual production. I am making this video just for education purpose, to educate you guys how will you understand the design of full bridge converter, right? Now let me directly run the simulation and let me show you the different waveforms what we can see here. So go ahead, simulate button, edit simulation command, and you see the stop time is 4 milliseconds. So just click on OK, go at run button. At this time tile window vertically. Now let me show you the different waveform, guys. Let me show you the waveform here. So you see here, this is the waveform for high side driver. Okay, this is M1 driver. For M1 you can see this frequency, and let me zoom for you guys. Okay, this is M2. So you can see here your M1 driver. Here you can see M1 and M3 both should be in the same phase. So let me click on here M3. So you see this is M3 and this is M1, both are in the same phase and they are overlapping each other. Let me show you for M2. This is for M2 and this is for M3, and you can see M2 and M3 are overlapping together. Let me overlap M1 and M3 on this window. Okay, so you can see here we have some dead times between M1 pulse and M3 pulse. You can see this dead time. Okay, now I'm gonna show you the drain to source waveform. Let me delete this for you, and let me show you the drain to source waveform this time, right? Let me show you why this is not running. It is very slow. Yeah, it's glowing. Okay, that's okay, that's fine, not fully turned on. Okay, so this is drain to source voltage, guys. Let me show you the drain to source voltage, right? So you can see here we have the voltage and we have some here dead time as well. So this is the drain to source voltage. Let me show you the voltage across this transformer, how this looks like. Okay, so this voltage across this transformer is looks like this. Okay, now you can see also the current across this transformer. This looks like this. This is current across the primary. This is the voltage across the primary. Okay, and you can check the voltage across secondary. You can check the voltage this winding. This both are in the opposite, right? You can see the inductor current, how this is looks like. You can see, can you see guys, the inductor current? You can see also the output voltage. Okay, so you can see more or less. Let me run like this. Let me close this, run again, tile window vertically. Let me show you the output here. So this blue one is your output voltage and this green one is your output current. So you see here your output voltage is more or less 11.3. It is coming around 12 volt, 11.86, and if you look at the current, it is coming around 24.69. Let me show you the power for this converter, how much power. So you can see this again, red one is a power and which is coming around 291 watt. It's close to 300 watt. We need to modify, we need to tune some components here in order to get exact 300 watt power supply. But I am pretty happy that you are getting 12 volt at output, that is 11.86. You are getting the current 24.6 amps. So I'm pretty happy that this converter is working very properly. Okay, and it is giving the output what we wanted. Okay, so if you have any question on 300-watt full bridge converter design, feel free to ask me in comment section. Thanks for watching this video, guys.